My name is Nitesh Shet. I am from Hanara. So last class we discussed about a topic from 9th standard, that is polynomials. In polynomial we already discussed about types of polynomials and series of polynomial. So let us move on to the next topic, that is remainder theorem. Remainder theorem. I thought we heard this word remainder. Where we know that remainder word? So in division. So one of the basic mathematical operation of mathematics. So we already discussed about those mathematical operations like addition, subtraction, multiplication and division. In division there are 4 terms are there. We require 2 terms, that is dividend and divisor. After dividing dividend from the divisor, we got quotient and the remainder. So likewise remainder theorem is also belongs to the division. So we are keep on dividing the polynomials. So let us discuss about remainder theorem. So theorem is, there is some is a statement. So Pythagoras theorem having their statement. So all the theorem. So we already learned that those theorems having their statements. So that means remainder theorem also having their statement. The statement tells us that let p of x be a polynomial greater than with degree greater than or equal to 1 and a is a real number. Let p of x divided by the linear polynomial x minus a, then the remainder is p of a. So here we want a polynomial p of x with degree greater than or equal to 1. So whether it is linear polynomial or quadratic polynomial or cubic polynomial, there is a chance. So but the divisor is must be a linear polynomial here. So that means g of x is a linear polynomial. So I will take it as a x minus a. So after dividing those polynomials, we got the remainder. It can be expressed in the form of p of a. So p of x we know that also the remainder in the form of p of a. So let us know about the statement. Let p of x be any polynomial having degree greater than or equal to 1 and a be any real number. Then p of x is divided by linear polynomial x minus a, then the remainder is p of a. So we have some polynomial p of x. So having degree greater than or equal to 1. Degree means the power of a leading term or the highest power of the leading term is a degree. So p of x is any polynomial, the leading term having a degree of greater than or equal to 1. That may be linear polynomial or quadratic polynomial or cubic polynomial or by quadratic polynomial. So there is a chance. But divisor, there is no any chance. We have to must take a linear polynomial. We have to take a linear polynomial. After the division, we got a remainder. It's in the form of p of a. That means if we substitute the value of a to the polynomial of x. We have to take x is equal to a to the polynomial x. That means it turns into the remainder. So here we have to substitute the value of x is equal to a to this p of x. We got the remainder. So we have to prove that whether it is right or wrong. So prove. For proof, so we have to take any polynomial p of x. I will consider it as a p of x. Let p of x be any polynomial of degree greater than or equal to 1. So we have a polynomial p of x is having degree greater than or equal to 1. So we have to take the divisor. Let g of x is equal to x minus a. So it's a linear polynomial. We have this g of x is equal to x minus a. It must be a linear polynomial. So after division we got quotient and the remainder. So already you know that after the division we must get quotient and the remainder. So there exists a quotient and a remainder. Thus I will call it as a q of x and r of x. So there must be a quotient q of x and remainder r of x. Yes. So we have a polynomial p of x as a dividend, and we have a g of x is equal to x minus a as a divisor, and also we have a quotient q of x and the remainder r of x. So it can be expressed in the form of dividend is equal to divisor into quotient plus remainder. We already know the relation of division. After division we have to take in the form of dividend is equal to divisor into quotient plus remainder. So you already know that. So we have to express in that form. So after division, so how can we express this division? Is equal to dividend is equal to divisor into quotient plus remainder. So we have to substitute all the values. We know that p of x is a remainder and x minus a is a divisor and q of x is a quotient and remainder is a r of x. We have to substitute all the values into this equation. So what is dividend here? P of x. Then what is divisor here? X minus a is the divisor. Then what is quotient here? Q of x is a quotient plus what is the remainder here? R of x is a remainder. It is equation number 1. It is a very essential equation for our proof. So I will take this equation as a equation number 1. So the half part of this proof is completed. So next we have to go to the next part of the proof. We have to take the solution and we have to take the zero of the solution. So just observe here, p of x can be expressed in the form of multiple of x minus a. Here p of x is expressed in the form of multiple of x minus a. So that means x minus a is the one of the solution of the equation. So are you agreed that? Yes. So x minus a is the one of the solution of the p of x, means x is equal to a is the one of the zero of the polynomial p of x. So we already learned that. So if we substitute x is equal to a, after that the polynomial is 0, that means x is equal to a is the zero of the solution. So here also x minus a can be expressed as a multiple of p of x, means it's a one of the solution of the equation. So after that we have to take x is equal to a, one of the zeros of the polynomial. So A is the one of the solution of equation. So that means x is equal to A is the one of the zero of the polynomial P of x. So we have to substitute the value of x is equal to A in equation number 1. Substitute x is equal to A in equation 1 here. So we have to substitute x is equal to A. So P of x is equal to, that means in x we have to write A here. P of A is equal to x minus A, that means A minus A into Q of A plus R of A here. So A minus A getting cancelled. So P of A is equal to, so it is 0. R of A I will write it as a R. So that means P of A is equal to R and R is equal to P of A here. So the remainder is in the form of P of A. That means the remainder theorem is true. Remainder theorem is correct. So after division we can be expressed in the form of P of A. But the condition is that P of x is whether it is a chance. So whether it is linear polynomial or quadratic polynomial or cubic polynomial, whatever it may be. But there must be a divisor of linear polynomial. We have to must taken divisor as a linear polynomial, then the remainder theorem is true. So we got the proof of this theorem. So after the proof we get it as a right. It's the remainder theorem is a right. So let us take some of the example for proving this remainder theorem. So after taking the example we have to take the real polynomials. So we have to prove that remainder theorem. So let us take some of the examples. Divide x plus 3x square minus 1 by x plus 1. So this is the question. So we have to divide both. So whether we have to check whether remainder theorem is possible or not, because the P of x is any polynomial having degree greater than or equal to 1. So the leading term, the highest power of the leading term is 2. That means it's a quadratic polynomial. P of x is a quadratic polynomial. So there must be a condition that we must take the divisor as a linear polynomial. It's a linear polynomial. We have to take x plus 1 as a divisor and x plus 3x square minus 1 as a dividend. So let us take P of x is equal to 3x square plus x minus 1 and g of x is equal to x plus 1. So I will part this blackboard for my purpose. So here, so we have to divide these two polynomials, x plus 1 and 3x square plus x minus 1. So here, in dividing the two polynomials, we have to first consider the first term of the polynomial. So here 3x square and x. We have to first divide these two terms. 3x square by x here. So that means 3x is the answer. So here 3x can be write it in a quotient place. So here 3x is the quotient for the first division. So 3x into 3x square plus 3x plus 1 plus 3x. we have to change the sign here, minus, and here also minus. So after that it get cancels out, then minus 2x minus 1 is there. So we have, after that we have to continue the same procedure. We have to take the first term here, also we have to take the first term here. So in rough side we have to divide. So minus 2x by x is equal to minus 2 here. So we have to insert minus 2. So minus 2 into x is equal to minus 2x minus 2 plus 1 minus 2 here. So plus, and it is also plus. We have to change the sign. So then it get cancels out. Then we got the remainder as 1 here. So this is the division of two polynomials. So after that we have to express in the form of dividend is equal to divisor into quotient plus remainder. That is p of x is equal to g of x into q of x plus r of x. We already know that what are these terms. P of x is a polynomial of degree greater than or equal to 1. That means p of x is a dividend, it's a divisor, it's a quotient, and it's a remainder. So we have to express in this form. So what is the dividend here? 3x square plus x minus 1. What is the divisor here? X plus 1. Then what is the quotient? 3x minus 2 plus r of x. So here what we have as a remainder? 1. So it is equation number 1. So we got the remainder here. So we have to check the remainder theorem with the usage of this. We got the remainder as r is equal to 1. So here when we checking the remainder theorem, just consider remainder as unknown. So we don't know about the remainder here. So just take 1 is equal to r in equation 1. Take 1 is equal to r in equation 1. So what we get? 3x square plus x minus 1 is equal to x plus 1 into 3x minus 2 plus r here. We don't know the remainder. So it's equation number 2. Here the polynomial with degree 2, this quadratic equation is expressed in the multiple of x plus 1. So that means x plus 1 is the one of the solution of the polynomial. That means x plus 1 is the one of the solution of p of x. So x plus 1 is the one of the solution means x is equal to minus 1 is the. So when we take x plus 1 is equal to 0, that means x is equal to minus 1. So x is equal to minus 1 is the one of the 0 of the solution here. So that means x is equal to minus 1 is the one of the 0 of p of x. So we have to substitute x is equal to minus 1 in equation 2. After that we have to find the remainder of this division. So let us substitute x is equal to minus 1 in equation number 2 here. So let us substitute 3 into minus 1 square plus minus 1 is equal to minus 1 plus 1 into 3 into minus 1 minus 2 plus r we don't know, so we have to find out that term. So 3 into minus 1 square means 3 into 1 minus 1 is equal to minus 1 plus 1 0, the whole term vanishes, plus 0 plus r. So then 3 minus 2 minus 1, 3 minus 2 is equal to r here, then r is equal to 1. So here we got remainder as 1. Also here also we have the remainder as 1. While we make the division, so we got the remainder as 1. So when we take the remainder theorem, so then will be the remainder as 1 here. So that means the remainder theorem is true for all the polynomial p of x when we take the divisor as a linear polynomial only. So I hope you understood this remainder theorem. So let us go to the another problem. So let us we have to divide. So here p of x is equal to 3x raised to 4 minus 4x cube minus 3x minus 1, and g of x is the x minus 1. So we have to divide this and we have to find the remainder, and after that we have to check the remainder theorem. So I will part this blackboard. So here x minus 1 is the divisor and 3x raised to 4 minus 4x cube minus 3x minus 1 is the dividend. So you have to make your division. So just pause the video here and you have to make your division. So you don't wait for me to divide all these terms. So let us start the division. So 3x raised to 4, I will take 3x raised to 4 and here x, the first term of the dividend, first term of the divisor. 3x raised to 4 divided by x is equal to 3x cube. Here I will write 3x cube here. Then, so we have to multiply 3x cube minus 3x cube. So the minus term is plus term. I will change the sign here. It will get cancelled out. Then plus 3x cube minus 4x cube means minus x cube minus 3x. Then take the first term of the dividend and the first term of the divisor, minus x cube by x is equal to minus x square minus x square. I will write here. Then we have to multiply minus x square minus x cube minus x square minus x 1, that means plus x square. So we have to change the sign here. Then I will cancel out. Then we have to take, so here x is there, here x square is there. We don't have to subtract. So here we have to just write it. Minus x square minus 3x. So take minus 1 also here. So take the first term of the dividend and first term of the divisor. Minus x square by x is equal to, so what we get? Minus x here. Minus x plus x minus x square minus of minus plus x. So we have to change the sign here, then it will cancel out. Minus 3x minus x minus 4x minus 1. So then again we have to take the first term here, minus 4x divided by x is equal to minus 4 here. So we have to multiply minus 4 minus 6 minus 4x plus 4 here. So we have to change the sign. So it cancels out. Then we got minus 5 here. So we got the minus 5 as the remainder. So from this division method we got the remainder as 5. So from the remainder theorem we have to check whether it is right or wrong. So from the remainder theorem. So here we have to check the remainder theorem. From remainder theorem. So substitute. So x minus 1. So we have dividend is always expressed in the form of divisor. That means divisor is one of the solution. So then we have to solve that divisor. After that the value of x will be the 0 of the solution. That means here x minus 1 is there. So x minus 1 is equal to 0. Then x is equal to 1 is the 0 of the solution. So we have to substitute the value of x is equal to 1 to this polynomial. We got the remainder. So we have to check whether it is right or wrong. So p of x is equal to 3x raised to 4 minus 4x cube minus 3x minus 1 is there. So we have to substitute the value of x. So put x is equal to 1 here. P of 1 is equal to 3 into 1 raised to 4 minus 4 into 1 cube minus 3 into 1 minus 1 is. So here 3 into 1, 1 raised to 4 means 1. So 3 into 1, 3 minus 4 into 1 cube. 1 cube means 1. So 4 into 1 is equal to 4 minus 3 into 1, 3 minus 1. So what we get, plus 3 minus 3 getting cancels. Minus 4 minus 1 is equal to minus 5. That means P of 1 is equal to minus 5. So in remainder theorem we substituted x is equal to a. So here we have to substitute x is equal to 1. That means here there a and here 1. So after substituting the value of a and the value of 1, we got the remainder. So that means the remainder theorem is true for all polynomial x. So let us move on to the next problem. So here you know that after division we got the remainder, and after applying remainder theorem we also got remainder. Both the remainder are same. So that means the remainder theorem is right means so then after this we have to take the example, we directly go to the remainder theorem. So let us take P of x is equal to x raised to 4 minus 2x square plus x plus 1 and g of x is equal to x minus 1 here. So from this we have assumed that so P of x, g of x is the one of the solution of the equation P of x. So that means x is equal to x minus 1 is equal to 0. So x is equal to 1 is the one of the solution of the equation or one of the zeros of the polynomial P of x. That means we have to directly substitute x is equal to 1 to that equation. So that means P of x is equal to x raised to 4 minus 2x square plus x plus 1 here. So we have to substitute the value of x is equal to 1. P of 1 is equal to 1 raised to 4 minus 2 into 1 square plus 1 plus 1 here. So we have to substitute the value of 1. So is equal to 1 minus 2 plus 2. So that means 1 is the answer. So that means we got the remainder after division is 1. So you have to take the division, whole division. After that we got the remainder 1. So this is about the remainder theorem. So let us take any other example. So let us divide 4z cube plus 4z square minus z minus 1 by 2z plus 1. So we have to divide these two terms. So here we have just substitute the value of z or one of the zeros of the solution to the given polynomial. Here P of x is 4z cube plus 4z square minus z minus 1 here. So g of x is equal to 2z plus 1. So we have to take g of x is equal to 0, 2z plus 1 is equal to 0, z is equal to minus 1 by 2. So we have to substitute the value of z is equal to minus 1 by 2 to this P of x. Substitute z is equal to minus 1 by 2 to P of x here. So substitute P of minus 1 by 2 is equal to 4 into minus 1 by 2 whole cube plus 4 into minus 1 by 2 whole square minus of minus 1 by 2 minus 1. So we have to solve. So 4 into minus 1 by 8 plus 4 into 1 by 4, then plus 1 by 2 minus 1. We have to take the LCM of 8 here, so is equal to, or we can take the, we have to just solve or just reduce the equation here. So minus 1 by 2 plus 4 by 4, we can take 1 by 2 minus 1. So we have to take the LCM of 4 here. So then what we get here, we have to multiply 2 with 2 in the denominator and also 2 with the numerator. Minus 2 plus here we have to multiply with 1, here also we multiply with 1, 4 plus here we have to multiply with 2 and here also we have to multiply with 2 here. So minus here we have to multiply with 4, here also we have to multiply with 4 here. So let us take, so minus 2 plus 2 getting cancelled, plus 4 and minus 4 getting cancelled. So that means the value of u of minus 2, 1 by 2 is equal to 0. That means this polynomial is completely divisible by 2z plus 1. That means the remainder is 0 here. So this is about the remainder theorem. So I hope you understood this. You can take any other polynomial and we have to divide. After the we get the result as a remainder. So we have to introduce the remainder theorem, or we have to take the remainder theorem and find the remainder. Both the remainders are equal, but the thing that the divisor must be the linear polynomial. So thank you one and all. Be safe and stay home. Thank you.